September 4th, 1882, New York City Financial District, specifically at the corner of Pearl and Fulton Street, the Edison Company came up with the world's first electrical grid. Had 82 customers at the time, sported 100 or so street lights, and I think we could all agree that since then, our electrical system has come a long ways. Hi everyone, my name is Charlie Kirkpatrick. This video concerns cybersecurity in critical infrastructure. Now, you may ask, what do we mean by critical infrastructure? And your first inclination may be to think of the infrastructure as we discuss and learn in business and information technology, servers, clients, hardware, software, networks, the cloud, all that good stuff. Well, that's not what we're talking about here. What we're talking about here is all of the infrastructure that is required, in fact we take for granted every day, that we use to live our lives, basically. Specifically, what we're talking about here are electrical systems, agriculture systems that manage and provide efficiencies to the agriculture sector in America. Water, wastewater systems. We just turn the spigot on and it just simply works. We don't really think a whole lot about where our water comes from or how it gets there. But there's a lot of technology behind getting it there. And finally, transportation systems. Think rail systems, air systems, highway systems, all of the various technologies and systems that have to come together to move people and materials throughout the world. That's what we mean by critical infrastructure. Now, let's just take a minute to look at what might be a typical smart grid for our electrical system today. So on the left-hand side, you have the power generation facilities, be it coal or nuclear or wind or whatever the case may be. There's a massive infrastructure of transmission lines all throughout the country, electrical substations located every few miles to assist and boost that electricity. That electricity is then routed to every home, practically every home in America, every factory in America, every office in America. And then further think about this whole world of Internet of Things and all of the various devices from your phone to your watch to refrigerators to everything, thermostats, things of that nature that are connected to the smart grid today. Now think a minute. Think about how we manage this infrastructure. How do we know these systems are up and running all day, every day? Well, the answer to that involves a technology generically known as SCADA. SCADA stands for Supervisory Control and Data Acquisitions. This is a set of software and related hardware that is used to control, monitor, and then provide analytics for various industrial processes all throughout the world. And think in the manufacture of things, the management of the infrastructure that's required to deliver all of the things that we talked about earlier. In SCADA, there's a number of elements that I want you to be aware of. Number one, out in the remote plant areas, out in the infrastructure, there are sensors and actuators. These are small devices that are used to monitor and manage the flow of water, of air, of wind velocity, things of that nature. There's also small computers known as PLCs, Programmable Logic Controllers. These are computers that use sensors and actuators to help manage all of our critical infrastructure. PLCs are somewhat generic in fashion in that they can be used for everything from managing a wastewater facility to building nuclear bombs. Remote terminal units, these are devices that gather the information from the PLCs and then send that information, that data, through a telecommunications network that might consist of local area networks, wide area networks, the internet, and in all likelihood, a combination of all of that back to a corporate or governmental headquarters where you will find SCADA servers and SCADA clients. Servers where the information is stored and clients that are used to display all this information in an understandable fashion. Now, let's explore a little bit about each of these various elements of a SCADA system. First of all, sensors. These are small devices that are built into pipelines and such, and electrical systems that measure pressure, measures electrical flow, water flow, temperatures, light, humidity, wind speed, you name it. There's a sensor for just about any type of metric that you might want to manage. Actuators, these are small components of systems that are responsible for controlling valves, pumps, motor speed, things of that nature. They might trigger alarms or other critical action items when something goes wrong. Actuators will take information that's generated from the sensors and take some type of an activity based on that information or through control of a human, of course. Next is PLCs, Programmable Logic Controllers. These are computers that use the sensors and actuators and help manage those small devices, and are used in any number of industrial and critical infrastructure applications. Remote terminal or remote telemetry units. These are devices that primarily are responsible for communicating data from the field through a telecommunications system that might consist of a LAN, a WAN, the general internet, any number or combination or all of these telecommunication protocols that we have listed here. That information eventually finds its way to a headquarters where front-end processors are used to display complex information. All the information is gathered from the field in some type of a user-friendly format, something that you can understand, that a human can understand. Information is typically stored on SCADA servers. These servers log the data, are responsible for analyzing the data, and all the what-if analysis and things of that nature take place on the SCADA server. Here is an example, and it's just an example of what a SCADA user interface may look like for, in this case, a water tube boiler. The metrics, of course, that you see here would vary by application, but this is just one example of being able to take complex and voluminous information and displaying it in a usable fashion. So, to wrap up this video, number one, we introduced you and provided some definitions of what we mean by critical infrastructure. Then we explored the notion of SCADA, supervisory control and data acquisition systems, a collection of hardware and software technologies that are used to manage critical infrastructure. And then we did a little bit of a deep dive into the various components of SCADA, such as the sensors, the actuators, the PLCs, programmable logic controllers, remote terminal units that transmit data through a communications infrastructure back to headquarters, where you will find SCADA servers and clients that display the data. I hope you've enjoyed this video. My name's Charlie Kirkpatrick. I hope to see you in the future.